In this example of solving systems of equations, I'm going to demonstrate solving a system of equations using the process of substitution. This is the first one we're going to learn in the series. There are several ways to solve systems, and as you learn the different ways, you might develop a way that you prefer, or you might look at certain types of problems and recognize that one method will work better than another. And this is a very simple example of and a good example of when the method of substitution works really well. And the reason is because you have y equals, you have one of the equations already solved for y, which makes it primed for plugging into the second equation. Anytime that happens, you probably want to use substitution. Again, you may choose a different route, and that's fine. We're just going to learn all the different methods for solving systems of equations, and then you'll be able to make choices. So let's just go through this one real quick, and I've labeled them 1 and 2. So number 1, y equals negative 3x plus 5. Equation number 2 is 5x minus 4y equals negative 3. I have two variables, two equations. That denotes a system that I can solve using algebra. So what I'm going to do is I'm going to just substitute this whole number 1. It says y equals negative 3x plus 5. So everywhere I see y in this one, I'm going to substitute the negative 3x plus 5. So I'm just going to take number 2, and that's the one I'm really going to be working with. So I'm going to just remind you that I'm using number 2. I'm going to write out 5x, leave that the way it is, and then I come to a y. So I come to this y, and everywhere I see y, I'm going to replace what what this other equation designates as the value of y, negative 3x plus 5. So I'm just going to put that in there. So it's really a pretty simple step. 5x minus 4, parentheses, negative 3x plus 5, and then equals negative 3. Now what I've accomplished is I have everything in one variable. This is something that I can solve really simply algebraically. So now it's just simplifying this equation, the stuff that you learned early on in Algebra 1. So let's just go through the steps real quick. Leave the 5x alone. I'm not going to go into a lot of detail because I think you know how to do this stuff. This is a negative 4 plus minus 4 is a good way to remind you it's negative. So I'm going to distribute that through the parentheses. Negative 4 times negative 3x is positive 12x. Negative times negative is positive. And then negative 4 times a positive 5 is negative 20. So we've got the distributive property taken care of, equals negative 3. Now we have two variables we can combine, 17x, 5x plus 12x, minus 20 equals negative 3. Now, continuing to isolate for x, I add 20 to both sides. Again, I'm going through this relatively quickly because I think you know this part. And I end up with 17x equals negative 3 plus 20 is a positive 17. Continue to isolate for x, so divide both sides by 17, and I end up with, my answer is x equals 1. So that's part of it, x equals 1, but I have two variables in the original system, so I have to solve for an x and a y. And if you recall, in the end, I have to end up with a point solution, because the solution of the system is where the two lines come together and meet at a point. So I've got to go ahead and find that second point. Well, now that I know x equals 1, I can go ahead and fill that in. And then I'm going to use that, and what I'm going to do is I'm going to plug it into this first equation because it's already set up and simple, and I can probably even do it in my head. So y equals negative 3 times the one that I found, so I'm just plugging in, substituting, plus 5. So y equals negative 3 times 1 is negative 3 plus 5. Negative 3 plus 5 we know is 2. So my y is equal to 2. So the final solution, and that's kind of sloppy, is 1, the point 1, 2. So that's the place where the two lines come together, and that's where the solution exists.